Second day. Here we go. Going to solve a couple of things. We're going to use some of these skills from the other day. Write in log form. Whoa. Write in log form. Log. The base is 216. Take the log of the number, and the log is equal to an exponent. 216 raised to the 1/3 is 6. Over here, I'd put that up there. And then I would think about the fact that log base 5, it will be 6 times x cubed. And then we'll divide by the 48. We divide by the minus. And now I could simplify that to log base 5 of x cubed over 8. 6 over 48, 1 over 8. Boom, got it. Okay, which one is false? This one's good. Power rule. This one's good. We're going to do 6 over 3. Good. I don't know what's going on there. Let's check. This one's good. So this one is a problem. And there's nothing happening there. That should be log base a of 1 minus log base a of 3. That's what that would turn into. Log base a of 1 minus log base a of 3. That would be the quotient rule. This one's the power rule. This is good. This one's the quotient rule. That's good. Solve the equation, okay? A base raised to an exponent equals what you're taking the log of. This is really you could do this on your calculator, but it's really the cube root of 8, which is 2. This could be rewritten as the cube root of 8 all to the 4th, but you can raise it on your calculator, and you get 16. Over here, 27 to the 2/3 equals n. Again, the cube root of 27 is 3 squared is 9. Your calculator will do that for you, though. All right, big one here. Single log on the left, single log on the right. You can drop the logs. Must be just a single log and a single log. If I have other stuff added on, we're going to need to do something different. So at this stage, once you get log base b of x equals log base b of y, you can drop the logs. Just don't drop it on your foot. Okay, and now we got to move those over. X squared plus 6x plus 8 equals 0. Factoring. When am I ever going to use this in my life? Right now, brothers and sisters, right now. And I get this. And now I got to solve and solve. And I subtract the 2, and I subtract the 4, and x equals -2, and x equals -4. We must check our work. Negative squared is good. A negative squared is good over here. -6 times -2 is positive 12 minus 8 is positive 4. We're good. Remember, you can't take the log of a negative, so we're looking for logs of negatives here. -6 times -4 is 24 minus 8 is 16. We are fine. Okay, so both of those answers work. Again, a log here, a log here. Drop the logs. You are allowed to drop the logs if it's a single log and a single log. That's when you can drop the logs. Move those suckers over. And so I went minus and minus. And now I'm going to factor. What do you multiply to get -20? Add to get -1. I get -5 and +4. Set them both equal to 0 and solve. Add the 5. I get 5. Subtract the 4. I get -4. Check your answer. 25. 5 plus 20, 25. -4 squared, 16. -4 plus 20, 16. Both of them work. All right. So now these are the same types of things. I'm going to bring this up here. And I'm going to do the quotient rule. So the first thing I have to do is get this to be into a single log on the left and a single log on the right. Next, now that I have single log, I can't drop the logs up here. You cannot drop the logs until you get a single log on the left and a single log on the right. And then you can do it, and it'll work itself out. Times 5 times 5, x to the 4th equals 625. And when I raise to the 1/4, I'm going to get x equals 25. Okay, x equals 25. Got to make sure you're not taking the. Excuse me. I'm going to get x equals 5. What am I saying? It's 5. Almost made my first mistake of the year. It's 5. The 4th root of 625. is 5. So 5 goes up in here, 5 to the 4th, makes ourselves work out, and we're fine. Okay, this guy right here, I need to bring this up there, all right? And I'm going to go log base 3 of x minus 2 squared, quotient rule, divided by 6 equals log base 3 of 150. And then I do log, drop the logs now, single log, x minus 2 squared divided by 6 equals 150 times 6 times 6. X minus 2 equals 150 times x minus 2 squared. 150 times 6 is 900. And now I'll square root. Technically, I should take a look at the plus or minus 30, which is x minus 2 equals 30, which is x equals 32. You really should look at x minus 2 equals negative 30, which is x equals negative 28. But if you come up here to negative 28, you can't take the log base 2 of negative 28, so that gets thrown out. So you do want to make note of that. You can only be 32. I guess that would be right here. Negative 28 minus 2. So the answer is 32. Okay, again, drop it. X squared minus 2x equals negative 5x plus, whoa, what happened there? What happened there? What happened? Okay, negative 5x, it's almost like I never even left, plus 10. Bring it over. X squared plus 3x minus 10 equals 0. Factor x plus 5 minus 2. X plus 5 equals 0. X minus 2 equals 0. X is negative 5. X is positive 2. Got to check our work now. Negative 5. Negative 5 squared is 25 plus 10, 35. 25 plus 10, 35. This one's good. 2 squared is 4 minus 4. 4 minus 4 is 0. And then I get negative 10 plus 10 is 0. Can I take the log of 0? 5 to some power equals 0. No, you can't make that happen. That's an extraneous solution. Remember, what you're taking the log of has to be a positive number. Okay, these are different. Pay attention. Right now, I got a single log, and a number. That's not a hashtag symbol. That's a number. Okay, so I'm going to put them together. Log base 6 of x times x plus 5 equals 2. Whenever you get it to a 1 log equals a number, you're going to need to write it in exponential form. Remember, the base goes booyah and goes underneath here, right? 6 squared equals that. So I'm going to do this. X squared plus 5x equals 6 squared. That's 36. Now I bring her back, and I get this. And I factor. And I get plus 9 and minus 4. X equals negative 9. X equals positive 4. Check your work. Are you allowed to take the log of a negative? You are not. The negative 9 gets thrown out. Check to make sure the 4. 4 plus 5 is 9, and we're good. So please make sure you notice the difference between log number compared to a log and a log. Then you can drop them. Here you have to write them exponentially. Same thing here. Log base 6 of x times x minus 9 equals 2. Isn't this the one we just did? Oh, no. It's not the one we just did. Very similar. 6 squared is 36. Maybe you do it this way. That's okay. 36 equals x squared minus 9x. I would bring this way. 0 equals x squared minus 9x minus 36. And now we factor and set it equal to 0. What do you multiply for negative 36 and add for 3? Negative 12 and positive 3. Set them equal to 0 and solve. Add 12. Subtract 3. Can I put a negative in there? I can't. The answer is 12. Notice this one, log. If you've got log, then you're going to do it the other way. So I'm going to put this up in here. Log base 7 of x squared equals log base 7 of 27 times 3. Drop the logs. Okay, notice the difference. Log number, log. You're going to want to recognize that. And I get 81. Square root is going to be plus or minus 9, but is it going to make any sense? to be negative. You can't take the log of a negative, so it's just the positive. Log number. Where did this come from? Came from a while ago, I think. Whoa. Magic eraser. Lovely. Log number. Whenever it's log number, I'm going to multiply n times n plus 4 equals 5. And now I'm going to write it in exponential form. 2 to the 5th equals n squared plus 4. 2 to the 5th is, 32. Minus 32 from both sides. 0 equals n squared plus 4n minus 32. Factor! And you get n minus 8 and n plus 4. Set them both equal to 0 and solve. N equals 8, n equals negative 4. Can you take the log of a negative? You can't. Throw it out. The answer is 8. The magnitude m of an earthquake is measured by the Richter scale using the formula m equals log 10x. That seems important. Remember, we talked about the fact that if there is no base written, the base is 10. Actually, no. This is a misprint. This should look like this. Log m equals log base 10 of x. I'm glad I'm making the video before I'm teaching the lesson. Where x is the intensity of the seismic wave causing the ground motion. So this is an earthquake. Richter scale is base 10. An earthquake near San Francisco measured 5.6 on the Richter scale. That's M. The famous San Francisco earthquake in 1906 measured 8.3. How many times more intense is the big one in 1906? Okay, so what we're doing here is m, which is 5.6, equals log base 10 of x. That means 10 to the 5.6 equals x. X equals 10 to the 5.6. And then when you do it with 8.3, 8.3 equals log base 10 of x. That is x is 10 to the 8.3. So how do you figure out how many times more the big dog was? You do 10 to the 8.3 divided by 10 to the 5.6. Well, how do you divide things with the same base? You subtract the exponents. So I could go 8.3 minus 5.6 must be about 2.7. This would be 10 to the 2.7. So when I put 10 to the 2.7 in my calculator, I get 501. So this is about, so this seems like these seem like fairly close together, the 8.3 and the 5.6. They're both large earthquakes that did a lot of damage, but that is 500 times larger. 500 times larger, or excuse me, 500 times more powerful. That's what they're saying there. So you're gonna compare the two numbers. And then the other one there, let's erase this. The other one says, then more research indicates it was more likely 7.9. It wasn't actually an 8.3, it was actually a 7.9. They overestimated in 1906. Their computers must not have been working right in 1906. How many times greater was in intensity was Richter's measurement than what it ended up being? So now you're doing 10 to the 8.3 divided by 10 to the 7.9, and that would be 10 to the 0.4. So I'm going to go 10 to the 0.4, and I'm going to get 2.5. So he measured it as 2.5 times, and that's the whole idea of exponential growth. That's fairly significant, I would say. 2.5 times greater as a measurement was the error that he had, but we'll cut him some slack in 2006 because they probably didn't have a computer. Okay, there you go. That's your homework, and have a wonderful day. Do good deeds.